Hello everyone, welcome to another video by Simplilearn. In this video, we will learn about Arduino. The Arduino platform has grown in popularity among those just getting started with electronics and for good purpose. In contrast to the majority of earlier programmable circuit boards, to load new code onto the Arduino, you don't need a separate piece of hardware. All you just need is a USB cable. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon so you never miss an update from Simplilearn. So without any further ado, let's get started. What is Arduino? Arduino is an open source electronic gadget that reads input such as light on a sensor, a finger on a button, or a tweet and generates output based on those inputs such as turning on an LED or activating a motor. Arduino was created at a design institute as a simple tool for students with no prior experience with electronics or programming. Arduino boards are microcontrollers, not entire computers with operating system of their own, like the Raspberry Pi. Arduino just runs C or C++ code that is stored in the firmware. The Arduino IDE is free software that allows you to create and upload code on an Arduino board. Why Arduino? Arduino has been used in millions of projects and applications due to its simple and accessible user interface. The Arduino software is simple to use for beginners, but it is customizable for advanced users. It works on Mac, Windows, and Linux systems. Arduino is a valuable tool for learning new skills. Anyone, including youngsters, amateurs, artists, and programmers, can begin tinkering by simply following the step-by-step instructions. It can be used by teachers and students to create low-cost scientific equipments, to demonstrate chemistry and physics principles, and to begin learning programming and robotics. Designers and architects create interactive prototypes, while musicians and artists create installations and try out new instruments. Features of Arduino. Arduino has microcontroller of Atmega 328 and the operating voltage is 5 volts, whereas the input voltage is recommended to be from 7 to 12 volts and input voltage limits from 6 to 20 volts. We have digital input-output pins, that is, we have 14 pins, and we have analog input 6 pins, and we have DC current per input-output pin 40 milliampere, and DC current for 3.3 volt pin is 50 milliamperes. And we have flash memory of 32 kilobytes, and we have SRAM of 2 KB and EEPROM of 1 KB, and we have clock speed of 16 MHz. Now let us look at the different types of Arduino boards present. Firstly, we have Arduino Uno. Arduino Uno includes everything you will need to get started. It has 14 digital input-output pins, 6 analog input, a USB port, a power jack, and a reset button. Among other features, it comes with everything you will need to get started with the microcontroller. Plug into a computer with USB cable or power it with an AC to DC adapter or battery. Next, we have LilyPad Arduino. LilyPad is wearable e-textile device created by Lee and designed in collaboration with SparkFun. Each LilyPad was cleverly constructed with large connection pads and a flat back to sew conductive thread into garments. In addition, the LilyPad features its own set of input, output, power, and sensor boards designed exclusively for e-textiles and can even be washed. Arduino Mega. The Arduino Mega is the larger brother of Arduino Uno. It contains many digital input-output pins, that is 54, and 16 analog inputs, a USB connection, a power jack, and a reset button. It comes with everything you will need to get started with microcontroller. Plug it into a computer with USB cable or power it with AC to DC adapter or a battery. Breadboard Arduino. The Arduino IDE can program the breadboard over the use of Mini B connector. It will run on Windows 8 without requiring changes to your security settings. Because of the USB chip we used, it's more sturdy and it's fully flat on the back, making it easier to integrate into your projects. And we have Arduino Leonardo. The Leonardo is Arduino's initial development board with a single microcontroller and USB port. As a result, it may be less expensive and easier. Additionally, because the board handles USB directly, code libraries are available that allow the board to imitate a computer keyboard, mouse, and other components. Now let us look at the advantages of Arduino. In comparison to the other microcontroller system, Arduino boards are comparatively affordable. The Arduino's module, its cheapest version, can be assembled by hand, and even pre-made Arduino module cost less than $50. For Windows, Macintosh OS X, and Linux, the Arduino software IDE is provided. The vast majority of microcontroller systems are Windows only compatible. The Arduino software is simple for beginners, but it's also flexible enough for advanced users. For experienced programmers, the Arduino software is available as an open source tool to extend. People who want to learn more about the language can use C++ libraries, and those who want to learn more about technical specifics can switch from Arduino to AVRC programming language. The Arduino is an open source and has hardware that can be expanded. The Arduino board blueprints are made available under Creative Commons license, allowing experienced circuits designers to create their module version, extending and upgrading it. At last, we will look at the disadvantages of Arduino. Arduino cannot run multiple programs at a time. No memory safety checks. Expensive for CPU power and memory. It has lack of built-in communications. Lack of built-in peripherals. The limited number of programming languages. And a limited number of IDEs. Locking projects using Arduino. Frequently, we need to secure a space in our home or business so that no one can enter without our permission and our valuable accessories and assets are protected from theft or loss. There are many different types of security systems available today, but they all rely on fingerprints, retina scanners, iris scanners, face ID, tongue scanners, RFID readers, password pins, patterns, and other biometrics for authentication. The most cost-effective solution is to utilize an Arduino-based password or pin-based system. Some of the locking projects using Arduino are Arduino door lock system, RFID and keyboard lock system. We have unlock door with knock system, push button lock system, and gesture control lock using Arduino. Then we have rover projects using Arduino. The Arduino robot is the world's first Arduino-powered vehicle. On each of robot's two boards there are two CPUs. The motor board is in charge of the motors, while the control board is in charge of reading sensors and deciding how to run them. Each board is a complete Arduino board that can be programmed using Arduino IDE. Using Arduino, we can create many rover projects like voice controlled rover, line follower rover, gesture controlled rover, survey rover, IR remote controlled rover, and similarly, we have autonomous rover and many more. Game projects using Arduino. Some remarkable Arduino-based game projects ranging from retro gaming played on a little screen to more sophisticated projects requiring some assembly. Some of the Arduino gaming projects are Snake Game, then we have Chess Game, Pinball, Spaceship Simulator, and Claw Machine. Automation projects using Arduino. The robust characteristics of Arduino are well suited to a popular section of applications, that is automation. The Arduino board can be used to create a wide variety of automation applications. Automation has brought convenience to a whole new level, from controlling room lights with your smartphone to automatically organizing events. Instead of using mechanical switches, you can now operate all of your home electronics from the palm of your hand. Some of the automation projects using Arduino are home automation, hand sanitizer dispenser, automated shower boiler, automatic motion sensor trash, and IR remote controller home appliances. Health projects using Arduino. Any medical equipment that has internet connectivity and can measure one or more health data of a patient who is connected to the device, such as heartbeat, body temperature, blood pressure, ECG steps, etc., is referred to as Arduino-based patient health monitoring system. If there is a rapid change in patient's health, the equipment can record and transmit the data. IoT encompasses everything from smartwatches to fitness tracker to hospital equipment that can link to the internet. Arduino-based health projects are being developed to create new medical gadgets. It may be used to measure body factors such as ECG, temperature, moisture, and heartbeat. It also identifies the patient's physical state and location. Some of the health projects using Arduino are Smart Wristband, Smart BioWare, Portable ECG, Ultrasonic Sight, and Smart Health Kit. Drone projects using Arduino. Drones are airborne vehicles that range in size from micro to multi-rotor quadcopters. A camera is sometimes included with the drone, allowing the users to watch and record the bird's eye perspective. A drone is made up of numerous parts, one of the most significant of which is the flight controller, which acts as the drone's brain. The Arduino development board is great for this purpose, especially because there are a variety of models available ranging from the tiny Arduino Nano to Arduino Mega, all of which are small enough to fit into the design of a drone. Some of the drone projects using Arduino are quadcopter, autopilot drone, mind control drone, guide power drone, and hovercraft. Robotics project using Arduino. We can learn about electronics, mechanics, and software using the Arduino Robotics project. It includes a number of project examples that you can easily copy, as well as robust robotics platform that you may have to execute a variety of jobs. Some of the robotics projects are robotic arm, drawing robot, firefighter robot, ball tracking robot, and spider robot.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
Audio projects using Arduino. If you enjoy working with both hardware and software, Arduino is the perfect hobby for you. Arduino is a programmable, logical controller that can do a variety of cool things depending on your programming skills. Using the Arduino to make music is a special genre of projects. If you will, some are straightforward to implement while others are more difficult. So some of the Arduino projects for audio are Paper Piano with Arduino, VFO or RF generator, Arduino MP3 player, Arduino Uno guitar pedal, and Arduino beat detector. And we even have mini vintage internet radio, Morse code communication using Arduino, and many more. IoT projects using Arduino. Arduino IoT Cloud is a tool that allows creators to create connected products quickly, easily, and securely. Multiple devices can be linked together and data can be exchanged in real time. You can also keep an eye on them using a simple user interface from anywhere. Some of the IoT or Bluetooth projects using Arduino are IoT bicycle radar, IoT pet feeder, Telegram bot, Arduino Bluetooth camera, and smart parking system. Sensor projects using Arduino. One of the aspects that make an Arduino so valuable is the simplicity with which it can retrieve sensor information. Sensors are devices that transform a physical quantity into an electrical quantity, such as light intensity or temperature. The different types of sensors that are available are light sensor, motion sensor, temperature sensor, magnetic field sensor, gravity sensor, humidity sensor, moisture, vibration and pressure sensor, electrical field sensor, sound sensor, and position sensor. Manufacturing, machinery, aircraft, vehicles, medicine, and robotics are just few of the use cases of these sensors. So the different sensor projects that can be made using Arduino are temperature monitoring, smoke detection using gas sensor, 3D scanner, smart plant incubator, and water quality monitoring system. What is Arduino? Arduino is an open source electronic gadget that reads inputs such as light on a sensor, a finger on a button, or a tweet, and generates output based on those inputs, such as turning on the LED or activating a motor. Arduino was created at the Design Institute as a simple tool for students with no prior experience with electronics and programming. Arduino boards are microcontrollers, not entire computers with operating systems of their own, like the Raspberry Pi. Arduino just runs C++ code that is stored in the firmware. The Arduino IDE, Integrated Development Environment, is free software that allows you to create and upload code to an Arduino board. Now let us see what is Raspberry Pi. Raspberry Pi is a small, low-cost computer the size of a credit card that connects to a computer monitor or television and utilizes a conventional keyboard and a mouse. Raspberry Pi can do everything a desktop computer does, including accessing the internet. Using Raspberry Pi, we can watch high-definition videos, access spreadsheets, word processing, and play games. Raspberry Pi has a dedicated processor, memory, and a graphics driver, just like a PC. It also comes with its own operating system, Raspberry Pi operating system, which is a modified version of Linux. Raspberry Pi is also used in music machines, parent detectors, as well as weather stations and tweeting birdhouses with infrared cameras. Let us look at the comparison between Arduino versus Raspberry Pi. First, let us look at the control unit. Arduino is a member of Atmega family of microcontrollers. A microcontroller chip common on Arduino Uno boards is Atmega 328. The 8-bit AVR microcontroller family includes Atmega 328 microcontrollers. A surface mount Atmega chip is seen on some Arduino Uno boards. The Raspberry Pi is an ARM controller unit. Broadcom chips based on ARM's Cortex-A application processor have powered Raspberry Pi from its release. The Raspberry Pi 3 is the latest version of the Raspberry Pi, launched in February 2016. It has 1.2 GHz ARM Cortex-A53 CPU, making it compatible for the ARM63. It has 1.2 GHz ARM Cortex-A53 CPU, making it compatible for the ARM64 architecture. Architecture. The Harvard architecture is used by Arduino's CPU, which means that the program code and the program data have distinct memory. It is made up of two types of memories, program memory and data memory. The data is saved in the data memory while the code is kept in the flash program memory. Whereas in Raspberry Pi contains a single core ARM V6 processor running at 700 MHz, a video core, 4 GPU, and 512 MB of RAM. Its operating system and data are stored on SD card. Raspbian, a lightweight Linux operating system based on Debian, is officially supported by the Raspberry Pi. Licensing. Arduino is an open-source electronics platform that uses simple hardware and software to make it easy to use. It's for everyone who wants to make interactive projects. Arduino perceives the environment by receiving data from a variety of sensors and actuators to influence its surroundings. Raspberry Pi's hardware and software are both proprietary. Raspberry Pi has never claimed to be open source. Many aspects of it, particularly the software, are open source, but not all of it is. The Raspberry Pi has been criticized for having closed source components. Operating system. Arduino boards are single board microcontrollers with firmware and no operating system. A firmware program is a piece of software that is installed on hardware device. It doesn't have an operating system, but it does have a firmware which can be programmed using several IDEs, including the Arduino IDE. Raspberry Pi operating system for PC and Mac is Debian with Raspberry Pi Desktop. It installs the Raspberry Pi operating system desktop on PC or Apple Mac, as well as most of the recommended software that comes with Raspberry Pi operating system. Now let us look at the specifications. So we look at the specifications between Arduino Uno R3 and Raspberry Pi 3 model B+. So if we look at the system, Arduino has microcontroller system, whereas Raspberry Pi has single-boarded computer. Processor. Arduino has AVR at Mega 328P and Raspberry Pi has Broadcom. RAM. In Arduino Uno, we have RAM of 2 KB, whereas in Raspberry Pi Model 3 B+, we have 1 GB RAM. Clock speed 16 MHz in Arduino and 1.4 GHz in Raspberry Pi. Execution. In Arduino, single program can be executed at a time, whereas in Raspberry Pi, multiple programs can run at a time. Current. Current is 5 mA in both Arduino and Raspberry Pi. And GPU I/O pins, Arduino has 20 and Raspberry Pi has 40. And power consumption in Arduino is 175 mW and in Raspberry Pi it is 700 mW. Applications. Arduino is used in waving machines, traffic light countdown timer, parking lot counter, embedded systems, home automation, industrial automation, medical instrument, and emergency light for railways. Whereas Raspberry Pi is used in desktop PC, wireless usage, game servers, retro gaming machine, robot controller, stop motion camera, and time-lapse camera. Now let us look at the different types of Arduino and Raspberry Pi. In Arduino, we have Arduino Uno, LilyPad Arduino, Arduino Mega, Arduino Leonardo, Arduino Redboard, and Arduino Shields. Whereas in Raspberry Pi, we have Raspberry Pi 1 Model B, Raspberry Pi 1 Model A, Model B+, Model A+. Then we have Raspberry Pi 0, Raspberry Pi 2, Raspberry Pi 0W, and Raspberry Pi 3 Model B. Arduino or Raspberry Pi, which is better? The Arduino and Raspberry Pi have their own set of benefits and drawbacks. The best option for you will be determined by the requirement of your project and your budget. Arduino is ideal for automating repetitive operations such as opening and closing doors, turning on and off lights, and so on. Arduino should be the first pick if your project has any repeating elements and just requires generating output depending on sensory inputs. Raspberry Pi is ideally suited for complex activities such as controlling complex robots, weather monitoring, and internet publishing, among others. If your project necessitates advanced functionality as well as internet access, then the Raspberry Pi is the option. So with that, we have reached the end of this video. Thank you so much for being here. Keep learning and stay tuned to Simply Learn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.